I'm going to solve this system of equations using substitution. So notice that I have two separate equations. They both have x and y in them, and I'm trying to find the xy pair that makes them both true at the same time. So like if I plug them into the top one, left equals right. If I plug them into the bottom one, left equals right. So that's my goal. And this is nice because it actually tells me what x is in terms of y. So when I say equals, equals means identical. It means these two things are completely interchangeable. So that means if I have this x equals that, I can substitute that in for the x in the other equation. So this top equation, I could think of it as 3 times x. Well, I know x, it's 3y plus 10 plus 2y equals 8. And here's what's nice about that substitution is before I had it in terms of two variables, so I couldn't isolate it down, so I just got it equal to a single number. In this one, I'll have one variable. Like, notice that form. So if I only have it in one variable, that means I can solve for that variable and get a number answer for it, an equivalency. So now it's just solve. So distribute that 3, 9y plus 30 plus 2y equals 8. Combine some like terms over here, 9 of them and 2 of them is 11 of them, plus 30, 11 of those is 8. Subtract 30 from both sides. 11y is negative 22, divide by 11. Looks like y is negative 2. So I know what y is. And so now to figure out what x is, I can take this y value and plug it back into one of my original equations. So y is negative 2. I'm plugging it up here. So x equals 3 times y. I can substitute in the negative 2 for it. I know what it is. 3 times negative 2 plus 10. So that x is equal to negative 6 plus 10. So it looks like x is 4. And if I plug 4 and negative 2 into this top equation, it's going to work as well. So I can write my answer this way. Y equals blah, x equals whatever. Or I can also write it as the ordered pair. Remember, x comes first, y comes second. Those are both good ways to talk about that answer.